Okay, I'm just showing the video of this. This was vocab that you would have done last week after you got done with the lesson quiz. So if you didn't get that done, make sure you do, as I will be checking this again. So piecewise defined function, you'll have the definition of that, which I'll end up showing you also in these notes that we end up doing. And then you were supposed to have draw an example of each of these graphs, and then leaving space up to the side. So what I'm writing on the board today on these notes, you'll be able to write off to the side. Okay, so make sure you got all of those done, and then the concept summary at the end that gives you an example of the words, the actual algebra, and what the graph looks like. Okay, the workbook, page 9. You're doing this on your own, so I'm just going to briefly talk about it, but I will check this when you do the quiz on this section, so just making sure that you are aware of that. Okay, so getting started, hold on, maybe, okay. Oh my gosh, how about I just close this guy. Okay, here we go. Okay, so this was in your workbook, not in the book, in the workbook. You had this and you were supposed to, and they gave you a graph to do it on. You could sketch it on another sheet of paper if you need to. But you're going to make graphs showing the income for each store as you receive it if the teacher needs to buy 1 through 20 packs of guitar strings. Okay, so this one right here, which is from store B, sells bundles of 4. Okay, so you would buy a bundle of 4, then your next 4, then your next 4, all the way up until you get to 20. Okay, so 20 is going to be one of your numbers on your x-axis. Okay, going from 1 to 20, and then the y-axis would be your income. Okay, or price of how much it costs. Okay, so you're going to do the graphs on that, and then the 2 separate graphs. Then you're going to describe the shape of the graph for the store A, and describe the shape of this graph for store B, and then why are the graphs different. Okay, so you would write that on B. Okay, and then C, now you're going to compare the graphs stores A and B, the numbers of strings, and which one is cheaper to buy from. Okay, so I will be checking these when we do the lesson quiz to make sure that you got these done. Basically, one of them is going to be a straight line, and the other one's going to look like steps, basically going up. Okay, so again, this is for you to be working on. Okay, so starting on our first example. Okay, so in the vocab, I told you to write the graph. You didn't have to write the chart. Okay, so the graph off to the right has a red line and it has a blue line. These are actually 2 separate lines if we were to write the equations. Okay, they made them on one graph because at this location right here, okay, which is at 40 hours worked, okay, once she gets over 40 hours, her pay increases. So that's why there's a steeper slope to this. Okay. So going back to reading what they're graphing and explaining, in the paragraph it says, Alani has a summer job as a lifeguard. She makes $12 an hour for up to 40 hours each week. Okay, so that's a normal week. She makes $12 an hour. Okay, so overtime is what they're talking about in the next sentence. So if she works more than 40 hours, she makes 1.5 times her hourly pay, which they tell you what that is. Okay, so if you didn't know what that is, then you would go 1.5 times the 12, which gives you 18. Okay, so she's going to make 18 hours for each hour over the 40 hours. And it says, how could you make a graph and write a function that allows Alani's weekly earnings based on the number of hours she worked? Okay, so you can make a table if you want to. So if I work 20 hours, okay, then I would know that I would get 240. Okay, if I worked 25, it was 30. So that's what they just did. They just picked some times here to plot them on so that they can connect it to see what the line looks like. Okay, so up to 40 hours. Okay, then after that, then they graph just a couple more lines. Okay, so the 3 dots that they've had here, that's those 3 dots for 45, 50, and 55. To see what that line looks like. Okay, so this one's a constant rate of change, but then the rate of change changes on this one because she's getting paid more. Okay, so off to the right hand side is the equations and explaining what those equations are. Okay, so I want you to write this off to the right hand side. So when x is greater than 40, Alana's pay is P of X, okay? You don't need to write this right here because they simplified this down. So I'm just explaining how they got that. So you're gonna write when X is greater than 40, Alani's pay is, and then P of X, write this one right here, okay? So the one up above, they're explaining. So they're just saying that we know that for 40 hours, she's gonna get $12 an hour, okay? For 40 hours work. And then after that, so whatever your hours are, you're gonna subtract the 40 hours that you already got paid for. So say there was 42, then you go 42 minus 40, so only 2 of those hours are gonna get paid at 18. Okay, so all of that is put together. So this is the one that you're writing that is simplified. And that came from multiplying those two numbers together. So when I multiply 12 times 40, again, you're not writing this part, I'm just telling you where this part came from. So 12 times 40 would give you 480, because that's the max that she can make it to $12 per hour. And then from there, then you would just distribute this to make it more simplified. So that would be plus 18x, and then distribute the 18 to the 40, which gives you a negative 720. Okay, and then you combine your two like terms, which gives you the negative 240 to your 480 minus 720, which is that part. Okay, and then the 18 is that one. Okay, so again, you don't need to write the middle one because that's the longer version of it. The last sentence one that's underlined in black is the one I want you to write. Okay, and then the bottom one is just showing what the equation would be. Okay, so the red line, you're going to write this. So from 0 to 40. So when she works 1 hour, 2 hours, 3 hours, all the way up to 40, she gets paid 12. Okay. So the equation from here to here is this one, okay? And then the equation from this point on, so not at 40, but beyond 40, is this one, okay? So we have two separate equations, okay? So I'm scrolling down, so this explains our new vocab word, okay? Maybe go into the next page. Okay, so it says, step 2, notice that the plot contains two linear segments with a slope that changes slightly when it's at 40, okay, which is the red and the blue part. Okay, so it says a function that has different rules for different parts of its domain is called a piecewise defined function. Okay, so piecewise, this is what we're going to wind up doing. So you're going to write this next to the graph or below the graph of the one you just wrote. This is an example of a piecewise defined function. Okay, there's two separate equations. This was one of the equations, this was the other equation. And off to the side is the terms of each one of those equations. So if you're plugging in x and it falls between 0 and 40, you're going to use that first equation. If your hours are over 40, then you're going to plug it into the second equation. Okay, so piecewise function means that that line that's there, even though it continues on, has two separate equations for different parts of the line. Sorry guys, my mouse is going crazy. Okay, so continuing on, so this would be in your workbook, okay? So you would grab your workbook and you would write the answers in on this one, okay? So it says, and we're just going to use the two equations that we already had, okay? So in your workbook, if you need to write it so that you know where this came from, okay? And again, I don't care if you write it in your workbook or your notebook, as long as you know that this is the try it, not the example, okay? It's the try it. Okay, so we have our two equations that we're looking at. So if you need to write it in your workbook, do that. Okay, so if you're working 37 hours, you're not going to plug it into the second equation. You're going to plug it into the first equation because 37 fits into that location. Okay, it's greater than 0 but less than 40. Okay, so then I would just plug in 12 and then the hours that I'm working, which are 37. So you would multiply that. You would say, how much is she going to earn? Okay, so she's going to earn $444. Okay, so then this one is 43 hours, so 43 hours is greater than 40, so that means you're going to use that second equation. So where the x is at, I'm going to plug in the 43, because that's now the hours that she's working. Okay, so you would multiply those two and then subtract, and then her value for that one, for the B, is going to be 534. Okay, again, those are the ones that are in your workbook. Okay, moving on to the next example. Okay, here's our example 2, and you were told last Thursday just to draw the graph and then write it off to the side. So, okay, so I'm explaining where this graph is coming from. So this graph wasn't original. They're asking you to create that graph based on these functions, okay? So off to the side of your graph, I want you to write these functions. So you're going to write it as a set of x plus 11, and then the parameters for that are -10 is less than or equal to x, which is less than or equal to 2, okay? Remember on these, and looking at the graph that you already have drawn, that this would be a closed circle, this would be an open circle, okay? So closed circle, and we've got an open circle at -2, which if the other one wasn't drawn, you would see the open circle, okay? So that's why they changed it to blue. So this one's closed circle, so closed circle is blue. The red underneath was open, okay? And then the 2x minus 10 is now this one over here, and they're both open circle, so you've got the open circle there and the open circle there. Okay, but how do we get those graphed? Okay, so this is what I'm explaining. So after you wrote what I have in red right there, off to the side, if we were just to look at 4x plus 11, we would know it's a straight line, okay? But we would want to extend that line. So you would, and don't write this, okay? If we had y equals 4x plus 11, I would know that this crosses the y-axis, right, at 11. And then the slope from there is up 4 over 1, or you could go down 4 to the left 1. Well, if you notice that in this graph, they don't have that. 11 would be like way up here, okay, or up here, okay? And then you're drawing the rest of that. They don't want that. They gave you parameters. Okay, so what we're going to actually do is use the x values that they gave us, okay? So now you are writing this, okay? So we have two sets of x's that we are going to plug into our equation to get our y's, okay? So I would have two sets of parentheses, okay? My x's are a -10 and a -2, okay? I need to find the y's. So what I'm doing is I'm plugging it back in. So if I plug in 4 times a -10, okay, and then add 11, okay, so 4 times a -10 would be a -40, and then I would, which would be negative, I would add 11, and the coordinate winds up being, yeah, about -29, sorry. Double checking my graph. Okay, now I would do it again, but now I'm plugging in a -2 into the equation. Okay, so I have 4 times a -2 that I'm adding 11 to. Okay, so 4 times a -2 would be a -8. And when I add 11 to that, my new y value is 3. So if I were to graph these two coordinates, -10, 29, okay, so -10 would be over here, and then going all the way down 29, okay? And they had a bar below the inequality, so it's a closed circle, okay? Then if I were to graph this one, I'm going over, and they counted by 2s on the lines, okay? So I'm going over 2, and then the y's, they didn't go by 2s, it went by 3s, so then they went up 3. So technically this one is an open circle, okay? Because it's not got an equal below, okay? So then you would just do the same thing now for the next equations, and that's what gives you your shapes, okay? So that first one's a straight line, and this one is a straight line, but this one is going to be a parabola, okay, which they have right there for your parabola. So technically that one you wouldn't necessarily have to plug back in. You would know that the parent function of it would be at the origin. You just shift it down 1, which is what they did, okay? And then they give you parameters to it. So the furthest to the left is going to be is a -2, it's a closed in circle. Furthest to the right is going to be is a +2, and then they have a closed in circle, okay? But we know technically, like, those would go on forever, right? But they give you parameters. So there's multiple ways to do it. You can actually plug it in, solve for the y. Okay. So if you need to write that out as part of your notes so that you know how you got that, then you need to do that. Okay, so the next part says, what are the domains and ranges over what intervals is the function increasing and decreasing? Okay, so now we're answering this part right here. Okay, so scrolling down a little bit with what's in this part of your book, and then we're just going to write little things. Oh gosh, my mouse is acting up. To determine the range, calculate the y values that correspond to the minimum and the maximum x values of the graph. For this graph, the values occur in the endpoints of the domain of the piecewise function. So what you're looking at is back up here, your smallest x value is a -10. And then your largest x value is a +10. Okay? So that's where they got this part right here. Okay? Well, the -10 was in that first equation. Okay? So when we plugged in a -10, we already know what our y was, right? That was this part right here, okay? So we already know that. So when we plugged in a -10, I'm just going to write this down again, okay? This is going to help us figure out our domains and range, okay? Then the maximum number that we have is that number right there, which is 10. So smallest was -10, the largest is a +10, okay? And that one came from this equation right here, okay? So that means I need to find out what the y value of that one is. So if I plug in 10, 10 times 2 would be 20. 20 minus 10 is going to be 10. Okay, so this was my minimum, this was my maximum x values. And that's what they had written right here, okay? So your minimum is -10 and your maximum is a +10, which is the red underlined part that I have. Okay, so to evaluate those, they plugged them in and got a -29 and a +10. Okay, so -29 and a +10. So we've already done that. Okay, so the domain means that's the farthest to the left and the farthest to the right. Okay, so they have the domain written in set interval. Okay, so you're going to write this as your domain. Okay, so write that in your notes. And now the range are these guys. Okay, so my smallest number, okay, is a -29 and range is y's, so notice there's a y there, and then my largest number is a 10, okay? So there's your domain, and here's the range, okay? So you're going to write that out. Okay, so now we're looking at the function is increasing, and when is the function decreasing? So we're going to write these out, and I'm going to go back and explain. So increasing, you have this one, and that one. I'll scroll up so we can look at the graph. Write them down first, okay? Just write them off to the side. And then the function is decreasing only at one spot. Okay, so scrolling back up, if you need to pause this video to write those down, write those down. Okay, so the function is increasing from a negative, and remember when we write these, we're talking about the x values, okay? So this line right here, okay, this one right here is increasing, and the x values of that are at a -10 over to -2, okay? And that's that first increasing red line. Okay, then it's increasing part of the parabola, okay? So the part of the parabola that's increasing, I'm going to do it in green, is from here to here, okay? So that's the part they're talking about in that second one. So it's from 0 to 2, okay? And then are increasing again from this one, okay? So the x values of that one. So that one was from 2 to 10. Okay, so the only decreasing one we have, and I'm going to do it in black, would be this right here. So describing that one, that's why there's only one of them written there, okay, is going to be from a -2, which again is your x value, and then your x value on the other end is 0, okay? So that's your increasing and decreasing. Okay, so make sure that you have those written down. Okay, so now we're going to do the exact same thing. Again, this is in your workbook, but if you don't feel like you have enough room in your workbook and you just want to write it in your notes, that's fine. Again, this is not the example, this is the try-it. So when I ask you for try-its, these are different, okay? It's not in the book, okay? We're actually doing these together, okay? So if you were to graph these, and I'm just going to do a quick sketch of this, okay? And you would take time to do this when you go to do it. We're doing the 2x plus 5, the 2x squared, which means that that one's going to be a parabola, right? And then the other two are going to be straight lines. Okay, so to figure out what my coordinates are, I need to plug in a -6. So we're going to do these ones out. So I'm going to go 2 times a negative 6 and add 5, okay? And that's for my negative 6, and I'm finding my y. Okay, then I'm going to do it again for the negative 2, so I'm looking right here, so I'm plugging that in, times 2. Sorry, it's going to get the same answer. Okay, so when I plug in the negative 2, what did I get for my y? Okay, then you're going to do it again, and then you're going to do it for this one. Okay, so I have 2, and then I'm plugging in a negative 2 that I'm going to wind up squaring, and then subtract 7. Okay, so that's negative 2. Now I'm going to do it for 1. Okay, so I have 2, I'm plugging in 1 that I'm going to square, and I'm going to subtract 7. Okay, so that was me plugging in my 1. Okay, so now we're going to do it again. Okay, for this guy. Okay, so I have a negative 4 minus, and I'm plugging in 1. Okay, so that's for my 1 I got for my x's. Okay, and then I'm going to plug in 3. So it's a negative 4 minus 3. Okay, so when I plug in 3, I need to find my y values. Okay, so for the negative 6, so all the way back at the top, you would have got a negative 7. Okay, plugging in a negative 2, which gives me a negative 4. Negative 4 plus 5 gives me 1. Okay, so now doing the other ones. So a negative 2 squared is negative times negative is going to give me a positive. So 4 times 2 would make it 8. And 8 minus 7 would give me 1. Okay, so then the next one down, I'm squaring my 1, right, which is 1. 1 times 2 is 2. And 2 minus 7 is going to give me a negative 5. Okay, now my last set. So a negative 4 minus 1 is going to give me a negative 5. Okay, and then a negative 4 minus 3 is going to give me a negative 7. Okay, so then when we go to graph these, and again, this is just rough sketch, okay? So my x and my y. So I'm going to have a negative 6, so 1, 2, 3, 4, 5, 6, going down 7, 1, 2, 3, 4, 5, 6, 7. Okay, but I've got to look, okay, what I just graphed, I need to look to see if it's an open circle or a closed circle, okay? So for this one, it's going to be a closed circle, okay? So I have a closing graph. Okay, so now I'm looking at this one, so it's a negative 2, 1. Okay, so I'm going over 2, up 1. And again, if I'm looking at my graph, right, it's a closed circle. So I can connect those two. I know it's a straight line. Okay, so my next one's going to be a parabola. So the red one's going to be parabola. So I go negative 2. So I'm going over negative 2, which I already had a dot there, right? And up 1. Okay, so it's the same one, but that one would be an open circle. So I'm just going to do it looks like that. This is closed circle below it. Okay, and then my other one is 1, negative 5. Okay, so I'm going over 1, 1, 2, 3, 4, 5. I guess it'll probably be this one. Okay, so that's going to be my open circle again. Okay, open circle again. Okay, but I know it's going to be a parabola. Okay, and a parabola, this tells me that it's going to be at a negative 7 because of that guy right there. Because remember when we had, if it was just x squared, you'd be at the origin. But when it's minus 7, it's not in parentheses, that's an up-down thing, so you would go down to 7. Okay, so I said that was 5, so we'll say 6, 7. Okay, so that's the bottom of my vertex. Okay, I don't need to worry about the pattern of my y because I already have dots figured out. Okay, but I know it's upright. Okay, so I would just have a u that goes through at 7 and comes out right there. Okay, so then the last part, oh, I did the other one green, I'll do this one at the bottom, is doing these guys. Okay, so I would go over 1, down 5, so over 1, down 5, which is this guy, and it's a closed-in circle. Okay, because we've got the closed-in circle for the 1. And then for the 3, it's going to be another closed-in circle. So I'm going over 3, so that's 1, 2, 3, and then down 7, okay, which would be right here, which was the bottom of the vertex for my parabola. Okay, and again, it's a closed-in circle, and that one's a straight line. Okay, so that is what my graph looks like. So it kind of goes like this, and goes around, and then goes down like that. Okay. All right. So now we need to figure out what the domain and range are. Okay, so the domain is the furthest, the smallest number, and then your biggest number of your x's. Okay, so and I'm going to write it off to the right. I'm going to erase this so that we can do b. Okay, so domains are my x's. Okay, so my domain for this, my smallest number, is a -6, and the smallest part of my equation is going to face it. Okay, and because it's a less than or equal to what is coming from this part right here. Okay, so I already knew that. Okay, we're talking about x's. And then my biggest number is 3, and again, we're going to use the same symbol that was right there. Okay, so there's your domain. So now remember our ranges came from plugging in the smallest number and plugging in the biggest number. Okay. So when you plugged in a -6, so when you plugged in a -6, I was going to use my mouse, but my mouse keeps on. Okay, not going to use mouse. Okay, so when I plugged in a -6, I knew what my y was. Okay, so that's going to be my smallest of my y's. Okay, and now my other number, my biggest number, was 3. Oh, wait a minute. Something's not right here. Hold on a second. Because you can't have two of the same number. Something went wrong. Hold on. I gotta pause this video. Okay. So what we did in the last one is what they have in the book, but this will not work with the last option. Okay. So the -7 works, like what I had underlined there. The -7 works for your smallest number, because if we look at our graph, and you might just use this as your option. Okay. So because it's all connected, I'm looking for the smallest number. Okay. So the smallest, the furthest, all three of them combined go to was at a -7, which that is true with plugging it back in like we were talking about. Okay. So for my range, okay, it's going to be a -7. It's going to be the farthest down that it can go. But according to the way that we did it before, our biggest number was 3, and if you plugged 3 back into this equation right here, okay, this equation right here, that gives me a -7, and -7 isn't, that's my smallest number, not my biggest number. Okay, so this one's not going to make sense using that option. So we're just going to have to look at the graph and figure out where the y is at for that one. Okay, so where the y was at for that one was at 1. Okay, and that's the highest that it can go. Okay, and because 1 had the equal sign, then you would put an equal on there. Okay, so there we are in the book. Okay, so now we're listing our increasing and decreasing. Okay, so for our increasing, okay, and I'm going to use the little flat sketch thing that we had right here just so I can draw over the top of it. Okay, so we have an increasing right here, and we have an increasing right here. Okay, and then your decreasing, so that means you're going to have 2 of them, right? And then your decreasing would be this one and this one. Okay, so you're going to write increase and you just abbreviate. Okay, so for the increase, you have from -6, these are x's when we list them, okay? And because it was -6, I have an open circle. This should be a closed circle, so just on another figure. Okay, so -6x, and then it goes all the way up to the -1, and the -2, because that's the location for that one was 2. Okay, not 1. Looks like 1 on my graph, but it's a -2. Okay, we're going to have a -2. But that one was an open circle, so that shouldn't have an equals on that one. Okay, so let me erase that. If it's going to let me. Eraser. Sorry, my smart board's not operating. Well, okay, guys, just pretend like you can see that that's not there. So you just want less than, not less than or equal to. Okay, so now we need to write the other one. So the other one that's in red was from 0, okay, because it was at this location right there. Okay, so the other increasing one is at 0. And 0, because it's going up and going down, it's not going to have a bar below it, okay, which is your x. Okay, and then it's less than 1. And again, because there's something that's attached to it, okay, it's going to not have a bar below it. You're going to have that because it's also part of the up and down. Okay, if you don't have a bar, because it doesn't terminate there, it goes down from there. Okay, so now we're going to write the decrease. Okay, so the decrease is the green ones in the sketch that I did. So that goes from -2. Okay, so -2. Okay, and then because it's part of the increase decrease, we don't put a bar below it. We have x and 0. And then your other decrease, which is this guy right here. Okay, and again, that top one is part of something, so we don't put the bar below it. Okay, and then it goes over to this location, which is 3. But if we look here, it terminates. It's not part of anything else, and it has in your equation the less than or equal to. Then you would put that on there, because it was a closed circle. Okay. All right, so now we're doing that again for the B part. Okay, so I need to erase this. So if you didn't get all that, you need to write that down. And now we're going to try it for the B part. Actually, I'm going to have you guys try it. So pause the video. You're going to try this. I'm going to have people in class also try the B one, and then we'll check our answers to see what you got. Okay. Okay, so here to check your answers. Okay, so off to the right, these guys, okay, all these guys, I just put colored codes so you know what the graph looks like. So I plugged in the -4 into there, my answer is going to be 3. Plug in a -1, my answer is going to be 3, because there's no equation where you can plug in the x, okay? So now when I plug in 0 and I get 0, we don't put a -0 because 0 is 0. Okay, then when I plug in a 2 into the negative, it's going to switch it from positive 2 to a -2. Okay, plugging in 2 to the equation, you would get 1, because 3 minus 2 is 1. Plugging in 4 to the equation, and you get a -1. Okay, so now to graph them. So to graph them, we just got to pay attention to the inequalities as to whether it's an open circle or a closed circle. Okay, so at -4, 3, so we would go over, and I made a mistake on here because I think I was looking at this guy over here. I was looking at the 8. So we go over -4 and up 3. Okay, so technically that first one should be an open. Okay, and then the second one is closed. So then -1 up 3, then it's a closed circle. Okay, so we have a closed, and then you connect, which is a straight line, and that's why there's no x in there. There's no slope. Okay, then the next one down, you're graphing it 0, 0. Both of them had closed circles, so the reds are both closed circles, and it's a negative slope, so it's going down. Okay, then the next one, plugging in your values, and I have open circle, right? There's no bar below it, so open circle. If you look here, slope is always the x. What's in front of the x? It's another negative slope. Okay, so your graph should look like something like this. Okay, so now for domain. Domain is how far left, how far right. So the reason why we had to write 2 of these is because of this break that's in between. Okay, this was at a -2. Okay, this guy right here was at a -2. There was nothing at 1. Okay, so that means you have to have a break in between. So the domain goes from a -4 to a -1. Okay, and then from, oh, I said 2. So from -1, it goes to -1, because that's -1. Okay, then from there, it doesn't connect to 0, so we take a break. Then from 0, it starts off again. So we've got the 0, and then it goes, this one is this one right here is part of this one, so we don't have to take a break in between that one. Okay, so from 0 over to your x and your 4, which is this location. Okay. So now range is your lowest and your highest. Okay, So your range, my lowest right here, I'm going to put this in black. Sorry, so the lowest it went was right there. So that location is -2. And then the highest it went was at 1, right? But this is not, these two were connected to each other. So that's what gave us this one statement. This one is constant. Okay, the one that's up above it is constant. So there is no range in that one. It's the lowest and the highest. So in the book, they just put it and 3. Okay, they just put this. They didn't put the word constant. I added that on there just because there's no up and down. It's just at 3. Okay, constant. They didn't ask you for it in the directions. Okay, they asked you for the increasing and the decreasing. But if you did write the constant, then you would say, what is it for this x, for this y? It's a constant line, right? Because there is no range, it just was at 3. Okay, there is no increasing. None of your graphs went up. All of them were either constant or decreasing. So if I look at the red one, okay, the red one goes from 0 to 2. Okay, that's that guy right there. Okay, and then my other decreasing one, I'm going to make one red again, is this guy right here. Okay, it goes down, so you're listing the parameters of that. Okay, moving on. Okay, so here's our next one. Okay, so you were supposed to have drawn this and also drawn the chart, which my chart's kind of faded in the middle, but you were able to see it in your book. Okay. All right, so it says write a piecewise defined rule for a graph. What is a rule that describes the piecewise defined function shown on the graph? Okay, so basically this tells us that we're going to have 3 pieces. So they did them in, you can see them here in color. You have the blue, you have the red, and you have the black. Okay, so in your chart it corresponds. Piece A is the blue, piece B, and then piece C, I said black, but it's green. Okay. So it says there are 3 pieces for this function. For each piece, find the x interval of -2 to 1. So this right here has a bracket and parentheses. That means one of them is a closed circle. Okay, we've got a closed circle, and the other one is an open circle. Okay, and these values are the x values. So those are your x values. So that's all that they're listing there. Okay, so we're just looking at each one of those and the x values. Okay, so those are called your intervals, and that's where this comes in. And that is part of your piecewise, is to know your x's from beginning to end. Okay, for each one of those segments. Okay, but now we need to write the equation. Okay, so what they're using, and this would be in the way back for you guys. Okay, what they're using here is called the point slope formula. And so you can write an equation to a line if you know a point, just one of the points, and you know the slope. Okay. Well, in this, we don't really, sometimes you can find the slope by doing rise over run, just make sure it is right. But otherwise, we find slope by using the x's and y's of 2 of the coordinates. Okay. So if I'm looking at this first one, I have a -2 and a -10. Okay, it doesn't matter which one we're writing first. And 1 and a -1. So we can find slope as rise over run. So I choose the y's that I'm going to subtract from each other. So a -10 minus a -1, right? Whatever one I chose, then below has to be the one that's below at the x value. So minus my other x, which is 1. Okay, so these would change to positive. This would be a -9 over a -3, which gives me 3. Okay, so I just found my slope. Okay, so I found my slope, but now I need to use one of my points. Okay, so on this example, they chose the -2, -10. They chose that. It does not matter which one you choose. Okay, you're still going to get the same equation. Okay, so now that's going to this part right here. Okay, so now you're taking these values and you're going to plug it in. You have an x, you have a y, and you have the m. Okay, so the y, the x, and the m. So we plug those values in. So you have a -10, 3 was the slope, -2 was your x. So we combine those. So 3 minus 2 would make it -6, right? You move the -6 over to the other side, and that gives you b. Okay, so now we can rewrite the equation in y equals mx plus b because we know what the slope is, and now I know what the b is. Okay, so that's where this came in. And then they just did it for each one of them. Okay, so you're repeating the process for the red one and for the black one. Okay, we're going to practice this in just a minute. Okay, so I do think you need to write this off to the side so that you know at least where the blue line came from, and then you just end up repeating it to all the other ones. Sorry guys, I'm throwing stuff down in here. This is like the year of internet not working. For those in the future that are listening to these videos. Okay, so now we can write the piecewise function. Okay, so each one of these that we do this to, these are the equations. So our piecewise function would have the 3x minus 4. Then after we went through the steps with the red, we'd have x plus 3 as my formula. And then when we solved this one, it was just going to be a horizontal line, which you can look at this one up here. We've got a horizontal line, okay, at 8. Okay, so that's the other one. And then this just comes from your intervals, okay, your -2 and your 1. So what is your x of this one? What is your x of this one? So same thing here. What is the x of the red? What is the x of the red? So that's that one. So that is what you write off to the side. That's writing a piecewise function, okay, and writing the equation so you can figure it. Okay, so now it's our turn. Okay, again, try it. It's not in the book. It is in your workbook. So you either write it in your workbook or you make space in your notebook. Okay, if you're making it in your notebook, then that means you're going to have to sketch these so that you know what they look like. Okay, so I started number 3 just to save some time. You'll hear me write this in class, but again, I'm going to do the A with you, and then you're going to try doing the B. Okay, so my x values of each of my lines. Okay, so I'm just going to use probably the black right now. Okay, so I'm looking for the x values of these coordinates. So both of them were closed circle. So I'm looking at this guy right here. So there's my -5, and there's my +2. Or not +2. Should have been a -5. Yeah, that should be a -2. Those are my x values. Okay, so then my other x value, because it's the same one on here, I just put the negative on there. So now I'm looking at this guy right here, so that's a -2, okay, and that's going over to a +3, okay. And both of them had closed circles, so they were brackets. Okay, so now this one has parentheses because it's an open circle of my x value, and then a closed x value of that. So all that I've written there is just the interval notation thing, which you're going to use when we get done to write the piecewise. Okay, so we're going to have from a -5 being my smallest number, okay, and then -2 being my biggest number. And then I write it again, but I'm going to have a -2 be my smallest number, and then 3 being my. So when we write our piecewise, those are going to be the right side of the piecewise. Okay, so then from there, now I needed to use a point, right? And then this one was easy. I didn't have to find slope because if you look at this line, there is no slope to it. Okay, so I didn't have to find the other location and do the rise over run. Okay, so I already have that. Okay, so now I can plug it into my y equals, because now I have points and I have a slope, so I can plug it into the y equals mx plus 8. Okay, so my y was 7, my slope was 0, okay, and then I'm solving for, oops, sorry, my x was -5, because that's my x, and I'm solving for my b. Well, anything times 0 is 0, so basically all of this went away, so my b is 7, okay? So I can write my equation, and it would just be y equals 7, because there was no slope, okay? Which makes sense, it's a horizontal line, and it would, if I extended it, it would go through at 7, okay? So that's one of my equations that I'm going to write the f of x. Okay, so now moving on to the next one. So now I'm looking at this guy right here. Okay, so again, if you can find the slope by doing rise over run, do that. Otherwise, you need to know the 2 coordinates. So I'm looking at this coordinate and this coordinate. Okay, so I have them written there. So 3, 2, and then -2, 7. Okay, so I chose this to start with. So I did 7 minus my other y. Okay, which means if I start with 7, I've got to start with that. So I have -2 minus 3. Well, 7 minus 2 is 5. And -2 minus 3 is a -5. So a negative over a positive is going to be a negative. So now I have my slope. Okay. Again, you choose one of your points. I'm going to choose this guy right here that I did all of the underlining. That's my x and my y. Okay. So I can plug in my y. My slope was a -1, and my x was a -2, and I'm solving for the b, so I can write the equation. Well, negative times a negative would be a positive, so all of this became 2. But then I had to move the 2 over the other side and subtract it, which would be 5. Okay, so now I'm going back to y equals mx. M is my slope, so it's a -1x. And I just solve for my b, which was 5. Okay, so that's my other equation. So I have one equation, my other equation, then I'm going to write my piecewise, and now I need to find my last one. Okay, so I wrote these two close, but this one right here is now this. I'll do a different color. The red one right here that we're looking at. Okay, that's the one we're looking at. So my coordinates were 4, 5, and 6, 9. I needed to find out what my slope was. So I did 5 minus 9, so the black one's first because I start with 5, and then I have a 4 below it, so my slope was 2, okay? And I'm going to use this one as plugging into my equation, okay? So my y was 5, okay? My slope is 2, my x was 4, okay? And I'm solving for the b. So 4 times 2 would give me 8. If I move the 8 over to the other side, then that means my b is going to be a -3, okay? So now when I go to write my equation, it would look like this, okay? My slope was 2, right? So 2x, and then my b that I just solved for was a -3. Okay, so I'm going to take those 3 equations, and I'm going to write a piecewise function, okay? So looking at this guy first, okay? So I'm going to write a piecewise function. Okay, so it has the f of x, equals, and then our piecewise function has that bracket. Okay, so my first equation was y equals 7. Or I guess you don't need the y, sorry. Just write 7. I can even erase that. It's not y. You only write the right side of the equation. Oh my gosh. Sorry, guys. Okay, so you're just writing 7. Okay, and then now we're going to write the interval part that goes off to the right side. So usually to write a comma, I'm not going to be stickler about that. Okay, so we're using this right now to write our values for our x. So -5 is my smallest number. Okay, it was a closed circle. Yeah, we have a bracket. Okay, with the x, and then we have a bracket with the -2. -2 is my biggest. Okay, so now we're going to, I'm going to draw this one in green, I'm going to this equation right here, and this is the interval that I'm going to use for that one. Okay, so again, don't write the y like I just did on the last one. So we'd have a negative, what was our, did I just cover it up? Oh, my 5 is positive, I just didn't do a plus in there, sorry. Okay, so you can write it as a -1x plus 5. The way that they had it in the book was 5 minus x, which means the same thing. You have a negative slope. This technically would be the proper way, just because usually you write x's before the other one. Okay, then we're writing our interval notation. So you're going to have a -2 is less than or equal to x, which is less than or equal to 3. Okay. So now I'm going to my last one, so I'm using this equation right here, okay, so I would have 2x minus 3, and then you write your notation that goes with it, okay, so I have a parentheses, so that means that my 4 is not going to have the bar below it, and then my 6 is, okay, and that would be your piecewise function. Okay, so I want you guys to muddle through and try B. And I'm going to pause this video, and then you can check your answers in just a minute. Okay, So this one I actually thought was a little bit easier. Not that you didn't have to do it this way, but the first equation, okay, so I'm going to color these in black. I'm looking at this one right here, just going to draw next to it versus over the top of it. Okay, this one they were kind enough not to go by 2s or by 3s or anything like that. So you could find what your slope is on this one, okay? Because it's going down, right? And it's going down 1 over 1. So it was a negative slope, okay? And it doesn't cross through at anywhere, okay? So it would be a negative x. And then you just need to know what is your furthest left x and your furthest x on the right, okay? And so -3 was the furthest over here, and then the furthest just direction was -2. It had an open circle, so you'd have an open circle, okay? This one down in black, okay, it's a horizontal line, so there's no slope to it, so you wouldn't even have it, so you're just looking to see where it would go through the y-axis, okay? So this one actually did go through the y-axis, where this one over here didn't, but if we were to continue it, we could figure out what that one was, okay? So this one went through at 1, and again, you're just listing what is your furthest left x and your furthest right x. One was closed circle, one was open circle, okay? So this last one, I think, would probably be the only one that you would need to go through all your steps to figure out where it crosses the y-axis. So this part right here, okay? I think you could still find a slope on this one, because if I'm looking at this coordinate down here, I could go up 1, 2, 3, 4 over 1. So 4 over 1 would be what my slope is, right? So that's that part. But I don't know what my b is, okay? Because it doesn't cross in the graph that they have for us. It doesn't cross the y-axis. Okay, so to do that, you just pick one of your locations, which I did. Okay, I picked that one right there, which was 1, -1, and then I plugged it in. This is my x, this is my y, and this is my slope. Okay, so plugging it in, moving the 4 to the other side, so a -4 and a -1 gave me a -5, which gives me this part right here. Okay, so 4x minus 5 is my equation, and then my furthest x to the left was 1, and the furthest one to the right was 2, and both of those circles were closed. Okay, so I feel like that one had a little less work to it for you to get the problem done. Okay, so now we are going on to our next problem. Okay, so I want you to understand how the book explained it. I think there's actually an easier way to do this, so then I'm going to explain that as well. So you can use whatever method you want. I think both of them will work. It's just whatever one makes sense to you. Okay, so I had told you on Thursday to make sure you drew that graph. Okay, so that was one of them. And then you were supposed to write all the f of x ones from step 1. Okay, so I wanted you to write what the equation is that they are wanting us to break apart to look like this. Okay. And then this showed you the steps. So this was the third f of x thing that I wanted you to write. Okay, so make sure you have the graph written, and off to the side, it's this one, and then this is what I asked you to draw. Okay, all right, so reading what we got here, it says, how can you rewrite the function, okay, f of x, when the absolute value of 6x plus 18 as a piecewise defined function? So it says, write the function, they want us to break it apart. Okay, so they're showing us that you can break this apart by taking out a common factor. Okay, so I can divide a 6 out of both of those numbers. Okay, so that's what they're showing right there, dividing 6, and then you write what's left. Okay, so if I divide a 6 out of 6, there's an x left. If I divide a 6 out of 18, there's a 3 left. Okay, but notice our equation, that the way it is written is a minus. Okay, it's not a plus. Okay, so where that minus comes from is if you plugged in a -3 there into the equation, and the negative was there, and you're plugging in a negative, then it changes it to a positive. Okay, so that would mean that the vertex that I'm looking at, okay, my h and my k, right? We learned that hk, which was from our last section, is your vertex. So -3, 0. So the graph has 2 linear pieces, one to the left of x being equal to 3, which is the vertex, because we're talking about an absolute value. An absolute value is a vertex with an x. Okay, so find my mouse again. I'm disappearing. I'm so sorry, guys. Okay, scrolling this down. Okay, so we have our vertex. So our vertex is at 3, 0. So what they're talking about is we need to write a piecewise for this line and a piecewise for this line, okay? Well, there's something that we learned a while ago when we're solving equations, that when you have absolute value, you can solve those two equations because we don't know what's inside is either a positive or a negative, okay? So our original equation, okay, so I want you to write this out. So our original equation was f of x being equal to absolute value of 6x plus 18. Okay, so if I wanted to solve for y, okay, I would know that my possible, okay, would be negative 6 minus 18. That would mean switching everything on the inside. Or it could be what it is. Remember, we write it just like it is, but then we switch it and write it as its opposite, okay? Then these two right here are these two that they explained in the book, without you having to find the slope and do all that kind of stuff and choosing a point like what they have here, okay? We could write our two equations. Okay, so my slope would be a negative 6, because that's what's in front of the x. Okay, and then eventually it would cross at negative or positive 18 when it's going off to the right, and then flipping it over to the other side would be the negative 18. Okay, so when we go to write our piecewise is actually already in the equation itself. Okay, those are going to be our two equations that we're going to write. All that we need to know is just where our vertex is at, okay? So finding our vertex where the crossing point is at, which is going to be that part up there. Okay, so down below, and you're going to add this to your graph, this would be the piecewise function, okay? So writing it once with everything switched, writing it as the original, and then I need to know my x values of where my vertex is at, okay? This one here, so knowing which one is the less than, because both of them meet at that point, so one of them continues on, the other one we're writing it where it's equal to, so we don't know which one is the actual dot that's at the vertex. So the rule of thumb on this one is it's always the equation that's to the right. Okay, so on your graph, whatever this one is going to have the greater than or equal to. Okay, so this one is the positive slope. So the positive slope one would be this one. Okay, so you would always have the inequality, and that's your bigger one. This one would be your smaller one. Okay, and we're going to practice this so that that makes more sense. Okay, all right. So when it's to the right of the graph, where the x's get bigger, you add the equal to the equation, and then the other one is just less than. Okay, so this one's a lot quicker. Okay, so I know that when I go to write my piecewise function, right, I'm going to have the two equations. So I'm going to have this one written just like it is, so negative 5x minus 10, and then I'm going to have it written with the opposite sign. So now it's a positive 5x plus 10. So that's my other one, okay? So now I just need to know, I know this is a vertex, I need to know our vertex, a V-shaped graph, okay? I just need to figure out where that V is at, okay? So that I know what to write onto the right side of my piecewise. Okay, so to do that, we factored out something, right? I need to factor out something. So when I factor it out, I'm going to take the negative with it, okay? So anytime that starts with a negative, take a negative out. If it doesn't, then you're just taking the number out. Okay, so outside of the absolute value, I have a negative 5, and I'm rewriting what's on the inside, which is the x plus 2, okay? And that's what's left. Okay, so this part that's right here, just like our other one, this is really minus a negative 2 to get to the positive. So I'm using the negative 2, and then there's nothing on the outside here, so we just say that that's plus 0. Okay, because we didn't shift up or down, it's actually on the line. Okay? So our vertex to that is negative 2, 0, but we're only, when we write it out to the right, worried about our x's, okay? All right, so if I were to go to graph this, this would be at a negative 2, 0. So I go over to 0. This is my vertex, okay? This would be my negative slope one, which is a negative 5x minus 10. And then this one on the right, okay, this one over here would be my positive slope one that ends up going on, okay? And we're talking about absolute value because they didn't give us any termination on that, okay? So the one on the right, which is the red one, is the one that's going to have the inequality with the equals below, just like our last one. So whatever's on the right Sometimes it's upside down, so it would be flipped, okay, but it's not. It's this one that's on the right. That one is going to be your bigger one, and then you're going to put the -2. So then that means that this one is not going to have the bar below it, okay, and that's going to be your smaller one at a -2, okay. So the one on the right is always the bigger one with the equal to, and then whatever your x value is that you plugged in. Okay. All right. So now for, hold on, somebody's knocking at my door. Okay. So this one I'm doing with you just because it's a little bit different. You can't factor out a negative or factor out a 1/2 because this one over here was all inside the absolute value. This one is not. So this one's a little bit different. So I'm doing this one with you. Okay, so before we get started, we're just thinking about our last section. If I were to graph this, I know it's V-shaped, okay? The pattern's not going to be over 1 up 1 because of the 1/2 that's involved in that. But we're not graphing. I'm just going to visualize what we're looking at here, okay? So my original parent function would look like this, okay? So if I were to convert it to this one over here, this negative tells me that it's going down right? So it's flipping upside down, so it's not going V up, it's going to be V down. But this tells me it shifts up on the 3, okay? So that means it's going to go, it's upside down, but I'm going to go up 1, 2, 3. So this is where my B is at, and it's going to be going down right. Again, we're not going to worry about the pattern of it. I just know that it should look like that, okay? So when we go to write this, my vertex is not going to be at a number where the x is at with a number like that. My x for this one is 0. So that means my vertex is going to be 0, which is part of my piecewise function, okay? So we know we're going to write an equation, but over on this side, we're going to have zeros, okay? So remember when I said, when we go to write the one that has the greater than, it's always the one that's on the right, okay? Well, this one is the one that's on the right. So that means this one, I'll do it in blue, this one has a positive slope, and the red one has a negative slope. So the one that's on the right with the negative slope is the one that we're going to want to have the greater than or equal to, okay? All right, so going to write our equation. When we go to write our equation, we were writing it just like it is, right? And then we would write it with the opposite, okay? So the part that we're worrying about is this right here, okay? So if I were to write it just as it is, it still would come out and become a negative, right? Because if I write this just as it is, that's 1/2. But I have this negative on the outside, so switch it back to a negative, okay? That plus 3 is not changing because it's not inside the absolute value, so it's going to stay the same as positive 3, okay? So we have a negative 1/2 x plus 3. Okay, well now if I do the opposite, okay, because that first one I just brought out the 1/2, if I bring out a negative 1/2 and I have a negative on the outside, it's going to change it to a positive 1/2. And then again, the 3 was not inside the absolute value, so it doesn't switch. Okay, so we're just talking about when we're looking at the graphs, we have a positive slope and we have a negative slope. The one that has the negative slope, because that's the one that is on the right, doing the black again, visualizing, that's the one that's on the right has a negative slope, then that's going to be the one that's going to be the greater than. Okay, and then the other one is not. So the one on the right, whatever equation that belongs to, whether it's your first one you write or your second one that you write, that's the one that's going to be the greater than or equal to your value. Okay, guys, we are on our last one. Okay, last one, hopefully fairly easy. Okay, so this refers back to the very first one that you did with the strings, selling the packs of strings. Okay, so our the first store just sold one, so it would have been a straight line. But the ones that sell packets, your graph would have looked like this, okay? I didn't have you write this as a vocab word. It just means step function. So instead of a straight line, you have steps and then breaks in between. So yes, the X's continue on, like where it leaves off, but the Y's don't. Like you are not connected from one to another. So they just call them a step function. Okay. So reading through this. So it says the shipping cost of items purchased from an online store is dependent on the weight of the items. The table represents shipping costs you would incur on the weight for X. Graph the function. What are the domains and ranges of the function, and what do they represent? What are the maximum and minimum values? Okay, so if we were to draw this, these are the weights. Okay, so the weights for the first one, and then shipping would be going up here. Okay, so for the first increment, it goes from 0 to 2. So remember, we have open circles and closed circles, okay? And the cost is 5. So it's a straight line. So all of those in between there, so 0, 1, and 2, would cost $5, okay? Then to graph this one, it's not continued on from the previous one. Okay, so now if you order, okay, so this one continuing on from there. So 2 was an open circle, okay, inequality. Okay, and then up to 4 it would cost 8, and then 4 to 6 it's going to be 11, and then so on. Okay, so they graph the rest of the graph, which this was something you were supposed to write last week. Okay, so it says each y value goes with an interval of x values. So for example, at 5, when y was 5, that's a straight line, right? It's horizontal line, no slope. The interval was this to this, which is what they have up above. Okay, so just repeating. A closed circle means that the x value is included in the domain, which we use that, which we already know what this closed looks like, and then the open circle would not. Okay, so if we were to list the domain and range of this, the domain means the furthest to the left, okay, which is 0, because we have an open circle at 0, and over to the max one, which is at 8. Okay, that's really bad. That's 8. Okay, and it's a closed circle. Okay, so we have a closed circle, so it's going to be an inequality with the equals down below it. Okay, but range is different. Okay, because technically from 4 to 2, you go from 2 right to 4, and then 4 again, and it's like there's no break in the x's. Okay, but on the y's there is. So when we list the range for the y's, we're just listing what each one of them, where the increment comes out at. So this one was at 5, this one was at 8, okay, because there wasn't one at 6, there wasn't one at 7, so we don't list those, okay, for the range. There's breaks in between, so you just use commas, okay. And then the minimums and maximums, okay, so we have them here. So the minimum is talking about the y's, okay, so the minimum is 5 and the maximum was 14. Okay, those are your minimum and maximums. Okay, so really not too hard. Okay, we're going to go to the try it right now. So we're going to graph what it looks like, okay, with open circles and closed circles, and then we're going to say what the domain and the range and the minimums are, and then we are done. Okay, so I just drew the chart to get started. So the table below represents fees for a parking lot. Okay, graph the function, whether the domain is in the range of the function, and what do they represent. Okay, so time would be your bottom one. Okay, so time here. So it goes from 0 up to 12. So 0 would be here, 12. I made 12 hash marks going all the way across. And then the cost at the sides. So to me, it looks like they go by 5s. Okay, so that's what I did. I did 5, 10, 15, 20, 25, 30. Okay. All right, so graphing our first one. Okay, so at 0 and the cost being 10, so I'm going to make this 5, this one will be my 10. Okay, so we're going to have an open circle at 10, okay, and then it goes all the way to 3, which is a closed circle. So 1, 2, 3, so I'm going to have a closed circle here, and then we connect them. Okay, so now I'm going to do it again for the 15. So at 15, I have an open circle at 3. Okay, so 10, 15, open circle at 3. And then I'm going over to 6. So 3, 4, 5, 6. And this one had a closed circle. Okay, and I'm making my step function. Okay, so now and that was for 15. So now I'm at 20. So 15, 20. So at 20, it starts at 6, but it's an open circle. So I'm going to have an open circle. And I'm going to go over to 9. So 6, 7, 8, 9. I'm going to have a closed circle, and then you connect. Okay, then I'm on my last one, which was 25. Okay, and it's at 9. Okay, so I have an open circle at 9, and then it goes over to 12 with a closed circle. Okay, so that's what the graph looks like. So now we're looking at domain. Okay, so domain is the time. Okay, so we're looking at the x's. Okay, so it would be x values such that it would start at 0, and then these continue on, right? There's no break in between the x's. You have the open circle and closed circle where they were continued, right? 3, 3, 6, 6, 9, 9. So there's no break in between the x's for each one of those steps. Okay, so I have 0, and it was an open circle, so it doesn't have a bar below it, x, and then it's greater than or equals to 12, and 12 have the oops, okay, and then finish this up. So my domain is the hours. Okay, so now my range is going to be the money. So this is going to be the one where you're going to have breaks in between. Ranges are y's. Okay, so my range values for these are going to have commas. It was at 10, it was at 15, it was at 20, and it was at 25. Okay, and then there's my graph now. Okay, minimum and maximum, again, remember I said is your y's. Okay, so minimum and maximum. So the minimum is 10, the maximum is 25, and that's what we're looking at. Okay, so minimum and maximum is referring to the y's, not to the x's. Okay, so the only other thing that I had you write in the notes, which I don't need to go over, it was just something that you needed to write, was the concept summary, just so you have a sample of what they look like in the graph to refer to. Oh my gosh. So I'm not even going to click over on that because my mouse won't let me. So frustrating, guys.